Okay, so welcome to section 5.1 on addition of fractions. You should have your notes in front of you here as we work our way through this. First thing you're going to want to do is write your name so we don't lose your notes. Okay, so basically this chapter we're going to be working with adding and subtracting fractions. And we've got an example here that's going to show us how to do that. It says, after a long day marking tests, Mr. Trask has worked up quite an appetite, and as usual, he eats 1/4 of a blueberry pie and then 1/3 of an apple pie. How much pie did he eat in total? So one way we can represent fractions is pictorially, or by using pictures. So the first thing we're talking about here, 1/4 of a blueberry pie. I guess that would look something like this. I'm just going to divvy this first pie up into 1/4. So here's my 1/4 of my blueberry pie, and the apple pie, 1/3 of an apple pie, I can represent over here. We've got 1/3. So when dealing with fractions, you should remember from previous years, we have special names for the top and the bottom of our fractions. The bottom of the fraction is something called the denominator, and the top of our fraction is called the numerator. Now the problem with trying to add two fractions like 1/4 plus 1/3 is that the pieces aren't the same size, so we can't really compare them directly. We can look at it and estimate, but we won't really know what the total amount is unless we have, if we have a comparison we can make. So one strategy we can use for this is we can chop our pie up into smaller pieces so that they can be comparable. You'll see right down here, I've chopped this pie into 12 pieces. And the question I could ask myself is, how many pieces, when I look at a quarter, how many pieces of this other pie is that going to represent? So if this is my quarter right here, you can see that that's going to represent this same shape right here. And the question would be, well then how many pieces of this pie do we have? There are 1, 2, 3 pieces in that pie. And there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of pie. So my 1/4 of this pie here, it would be the same thing as 3/12 of this pie. And we have a special name for these two kinds of fractions here. We call these equivalent fractions. I can do the same thing with my apple pie. And if I take a look at my apple pie that was initially 1/3 of a pie, that would have a shape something like this. And we can see that that makes up 1, 2, 3, 4 pieces of pie out of a total of 12. So if I want to add the fractions 1/4 plus 1/3, then that would be the exact same as adding the fractions 3/12 plus 4/12. Now when I have the pie split up in 12s like I do here, it's a lot easier for me to compare those amounts. So if I have 3/12 over here and 4/12 over there, then my final answer is 7/12. Another way that we can represent that would be to look at this. If I have on this side here 1/4 of a pie, and on the other side I have 1/3 of a pie, we can see that when we put them together, we have just over half of a pie. If I put those in terms of equivalent fractions, we can see that even when I split the pie up into smaller pieces, the actual amounts of the pie are staying the same. And so right here I've got 3/12 of this pie and 4/12 of that pie. And when I put them both together, we get 7/12. So let's take a look at the pattern that we used in order to come up with our equivalent fraction. Our first fraction was 1/4. And we wanted to turn that into 3/12. One way we can do that is by multiplying the top and bottom by the same number. So I multiply top and bottom of this fraction by 3, I end up with 3/12. Similarly, when I had 1/3, how did I get to 4/12? Well, in this case, I multiplied the top and bottom by 4 to end up at 4/12. So if we ever want to get an equivalent fraction, we simply multiply the numerator and the denominator by the same number. And as long as we multiply the top and bottom by the same number, our fractions are still equivalent. Okay, let's take a look at one more example here. So in this example, we're going to add 4/9 and 5/6. And the problem here is that we can see that our two denominators are different. And we need them to be the same if we're going to add them together. The question is, what denominator should we use? What equivalent fraction should we look at? So the first step you should take is to find the multiples of your denominators. So let's find the first few multiples of 6. We've got 6, 12, 18, 24, 30, 36, and it goes on from there, but I'm just going to stop there for now. For 9, we have 9, and 18, and 27, and 36, and 45, and then it goes on from there. So what we're looking for is what number is going to give us the lowest common multiple, which is going to give us our lowest common denominator. And if we look right here with 6, we have 18, and 9 also has a multiple of 18. Because it's the smallest one that exists, we call this our lowest common denominator. And you may have noticed that later on 36 comes up again. We could use that, but it just makes things a little bit more complicated. So our next step is to create equivalent fractions. So for example, when I have 4/9, what will I need to multiply top and bottom by so that instead this reads something over 18? Well, 9 times 2 is 18. So 4 times 2 gives me 8, or 8 over 18. I can do the same thing with 5/6. So 5/6, and the question is, what can I do so that this is something over 18? Well, 6 times 3 is 18, and 5 times 3 is 15. So now that I've got my equivalent fractions, my last step is the easy one. I just add it up. So 8/18 plus 15/18 is 8 plus 15 is 23/18. And that's my final answer. Now you'll notice that when you look at this fraction, this is a special kind of fraction, and it's called an improper fraction. And the reason it's called an improper fraction is because the numerator here is bigger than our denominator. And that's okay. It's totally fine to leave it like that. Okay, that's the end of lesson 1.